Welcome to the Teachers to Tech podcast. I'm your host, Dean. This is the podcast where we tell you how you can grow your tech skills, whether you're starting from scratch or just want to go farther. You might be thinking about a new job, a whole new career, or just a new hobby. We'll have something for everyone, so keep listening. Welcome to episode 106 of the Teachers to Tech podcast. Today we're going to start a topic that'll fill 2 episodes, and that's databases. Like I always do, I'm going to start by explaining everything as if you're hearing it for the first time. That means even if you don't want to do any hands-on learning with a database, you'll still finish the episodes with a good understanding of what these programs are. Databases tend to come in many disguises, and by that I mean they take the form of specific applications. So it's very useful to know databases to understand what happens behind the scenes in those other applications. Databases are programmatic ways of storing our data. We can retrieve it easily, we can manipulate it easily, and they let us pull in information and answer questions based on that information. Now, the way we gather that data could be that we pull it in from a source in big chunks. So maybe a whole spreadsheet from Excel could be pulled into our database. Or we could enter just one record at a time where we go into a table of data and one field at a time enter first name, last name, phone number, etc. There is a way to make that easier too. We will talk about that in part 2. But for now, I want to focus on 2 parts of a database. And those 2 parts are the tables that hold our data and the queries that will let us look into that data, ask it questions. Let's start by talking about tables. Now, for human understanding, tables are displayed on our screen in rows and columns. They look like a spreadsheet. And the idea is we're able to identify what we're looking at based on the layout. Let's imagine that we want a set of records that contain the names and phone numbers of our friends. We would have a column labeled name and a column labeled phone number. And you could think of those as variables because we might record one friend's name, and that will be different from the next friend's name, but along with that friend's name will be a matching phone number, which will also be different. It'll always be name and phone number, but for each person we know, those will vary. So they're variables. But in databases, we often will refer to those as fields. Now, as we enter this data, it will be displayed back to us, if we're looking at a database table specifically, as rows, and we'll have a row for each friend, and we'll be able to see the name and the phone number paired up in the same row. Those rows are referred to sometimes as records, and that's what I will call them. Earlier in computer history, it was a large concern that we might use up data too quickly, and because of previous forms of databases, it was a concern that it was hard to get at some of our data. Imagine that every time a customer ordered something, we had their name, address, and phone number in with that order. But if we ever wanted to go back and find that customer's name, address, and phone number, we had to run through the orders until we could find one that customer had placed. That was a little bit of a problem that was overcome by the kind of database management system we're going to talk about, and that is the relational database management system. As I've clearly indicated, there are other methods of managing our data, but this one is common, and it'll help you understand what you see in several different types of databases out there. When relational databases were first developed, they had a couple of advantages for us. First of all, we could find records more easily. And the reason for this was because in older file types, we might have one line in a file that had a record of addresses, another that had a record, say, of customer orders. We would have to search through the data to find the addresses while looking for the correct address. And this made things more complicated and slower. But a bigger advantage from my point of view, and the one we're going to focus on now, is the idea that we could separate out data but keep it linked. So we would say we've got all our names and addresses of our customers in one file, and we keep records of their orders in another file, but by using a key, a field that is common to both, maybe a customer number, we could say, hey, this order is for customer number 123, and customer number 123 appears in this other table with this name and address and phone number. And now we only use that name, address, and phone number data when we need it, say to print out an invoice, and we don't have to carry it in every single record that has an order, which uses up a lot of space. A little earlier I said we might be worried about running out of data, and the way I probably should have said that is we might be worried about running out of memory space in which to place our data. So now we've gained that advantage back. I want to extend our example just a bit so I can make one more point about tables before we move on to queries. So let's imagine that the database we're talking about is used by a bakery. All of the customers for the bakery are in the customer table. That will include all the contact data and that key, the number or whatever identifier we use just for that customer, so that we can link it up with orders. We have another table called orders, and for every type of pastry that we could sell them, we have a quantity that they've ordered in this particular order. We can also make some calculations right inside that table. So let's imagine a third table where we keep all the prices for the type of pastries we sell. We can tell our order table, look at how many of these pastries were ordered, multiply it by the price you see for that pastry in another table, and put the result in another field in this same order table. When we go to print a report of exactly what was ordered, maybe it's an invoice, we can see every individual item ordered in what quantity, and we can also see the price extension total for that item. This is usually called something like a calculated field. We're going to wrap up today's episode with a discussion of queries. You can tell that the word query is related to the word question, and that's what we're doing here. We're asking our database questions. We can ask our database to show us subsets of our data using a feature called a query. In our bakery example, some practical examples of queries might request all the orders from a specific customer for a month to create an invoice, or maybe all the orders for a specific date to create a schedule or a supply order. When we write a query, we can request the fields we want in the output. We might want to get the customer name and address on an order to be used when it's delivered, and also the specifics of the ordered items. Later, on printing a monthly invoice, we might include the customer contact information, but then show only the dates for the month and the total cost of each order on those dates. Now, at this point, a couple of ideas might pop into your head, and you want to ask me questions like, hey, Dean, can't you just do this with a spreadsheet? Well, you could, but it's going to take a lot more work on your part to get that format that we just described. On top of that, most spreadsheets will not have a built-in reporting function like a database does, allowing you to print out something or email something as a PDF that's a lot neater looking document for the customer. The other thing that might come to mind is, Dean, they have specialized software for this. And I would say, I agree with you, but guess what that specialized software is? It's a pre-formatted database made so that it's tailored for whatever industry you're using it in. Hey, I'm a bakery, and so I have these pastries, etc., that I can use. That is what you're dealing with. In reality, it's a database, but you are seeing that somebody has taken the time to customize it for customers that specialize in a certain field. But we haven't really defined what a query is yet. A query is when we ask our database to look through our data and return to us all the data that fits certain parameters. So we might say, I want to see all the orders that have been put in by, say, the Johnson restaurant that needs my desserts. Or we might say, I need to see all the orders that were placed during this certain time period. Some queries can be written such that when we ask them to run, they ask us back, hey, you've told me you want to know something that happened, and you asked me to ask you for the date. whenever I run. So what's the date you need the orders for? Something like that. So we can have dynamic queries instead of having them all set up for just a specific date or a specific customer. They can prompt us at the time they run, and so we know we need the same types of information based on different settings in our parameters, and those queries can be that flexible. This is much easier than trying to figure this all out in a spreadsheet. When we run a query, we can see the output in its most basic form, displayed as a table on our screen. Now we can tell our query, when you run, we want you to create a table that's permanent in the database, or that could just be how the query is displayed temporarily on my screen. But the query itself is saved in the database, so I can run it again when I want to. Now these are very basic forms of output that I just described to you. Later we're going to talk about reports that databases can run. This is where we get to say, I want you to take that output and put it in the form of a document that I will format and create a layout for, such that it's repeatable and readable. It's good for customers and users alike to treat as a document and get to the information quickly. Let's sum up today's episode for a second. There was a lot of information. A database contains tables. Those tables are the places where we store the data that we're putting in. We can enter records directly into the table or use a form to put those in. Forms will come up in our next episode. When we want to get information back out of our tables, we may use a query, and the query will let us filter out selected records that we want to see and use based on parameters like specific dates or specific names of customers. Once we've selected specific data, we can decide what to do with that. One common thing to do with our selected data would be to put it into a report, a document that's easily readable by humans. We'll talk about that next time. Until then, thank you for listening. Be sure and subscribe and review us if you haven't done that already on your favorite platform for podcasts. And we will see you next time. That's all we have for today. This is Dean saying thanks for listening, and we hope to have you back with us next time on Teachers to Tech.